Today we're going to talk about a specific transformation called a dilation. So we're going to define and illustrate what a dilation is, and then we're going to talk a little bit about similar figures. Okay, so definition of dilation is obviously it's a transformation, and it's going to expand or contract the points of the plane in relation to a fixed point called P. Okay, so what does that look like? Well, here's our fixed point P. Okay, and then we have this preimage that's being expanded from point P to its image, right? And this ratio, the ratio of C prime to P, so from here, C prime to P, that distance to the distance of C to P, so this little distance here, so this whole distance to this little distance is called the scale factor or the K value of the dilation. Okay, so we always calculate K as a ratio or a fraction of the image to pre-image lengths. So you're going to get the distance from the image to the pre-image, right? So from the prime over the normal, okay? So if your K value is bigger than 1, then your dilation is an enlargement of the figure. However, your K is equal to 1, then that means there's no change, and it's the identity transformation. And if your K is less than 1, then your dilation is a reduction of the figure. So it can either be an enlargement, the identity, or a reduction. Okay, so when two geometric figures have the same shape, but not the same size. So think about triangles, right? Triangles that are the same, they're both triangles, but these triangles don't have the same size. They're called similar figures, right? So the corresponding sides are proportional, so they'll have the same amount of sides, and then they'll have the same angles. The corresponding angles will have to be congruent. All right, so let's do some practice problems. We want to find the image of point Q for the given dilation. Okay, so here's Q, the preimage Q, and we want to find Q prime. So the first thing we're going to do is we're going to see, well, where is the preimage in relation to our fixed point P? Here's our fixed point P, okay, and here is Q, okay, and here's A from our fixed point, and here's B from our fixed point. So this distance from B and Q, and this distance from A and Q, well, those distances have to be the same for our B prime. That distance has to be the same, and our A prime, that distance, okay? So, again, from B to Q, we can think the same. Well, B prime has to go to Q prime, so there's our Q prime. All right, now we are given the image, R prime, and we want to figure out, well, where is R? Where is the preimage? Where is R? So, again, we're in relation to O, our fixed point. Where's R prime? Okay, and then look at R prime to A prime. Look at that distance. And then we're going to use A to kind of gauge where our R should be. All right, so if O is our fixed point and we have a scale factor of K, we want to find K if the distance from O to A, or this distance here, our preimage, is 5, and then our image, our O prime to A prime, is 25, right? So 25 over 5 is our ratio, and that reduces to 5 units.
Hey, Mommy, look at it. I never was all the way by
Okay, so this one, we have a distance of OB, so this distance here is 3.5, and we have an O to B prime is 14, which means our scale factor is 4. Okay, and remember, if our K is bigger than 1, it's an enlargement, which makes sense because this became larger when it came over here. All right, now we don't have a picture. We just know that from O to C is 256, which is our preimage, and then O to C prime, which is our image, is 32. So remember, it is image over preimage, so it's 32 over 256, which reduces to 1/8 units, which means that it's a reduction. All right, your turn. You're going to do 12.3. You're going to do 2 through 6 evens.